Question 1, Part E. Find the values of x for which the absolute value of x minus 3 is less than or equal to 1. Using an algebraic method to solve the inequality, I can rewrite the original inequality, which uses the absolute value brackets, as a three-way or a three-sided inequality without using the absolute value brackets. In other words, I could write it as x minus 3 greater than or equal to negative 1 and less than or equal to 1. The next step is to isolate the variable x, and that'll give us our solution. Currently, 3 is being subtracted from x. And the inverse of subtracting 3 is adding 3. And we need to add 3 to all three sides of this inequality. So negative 1 plus 3 is equal to 2. X minus 3 plus 3 gives us x, so we've isolated the variable. And 1 plus 3 is equal to 4. Therefore, the solution is x is greater than or equal to 2 and less than or equal to 4. And here is the solution expressed using interval notation. Note the use of the square brackets because the endpoints of the interval are included in the solution. Using the critical points method, we treat the inequality as an equation, we solve the equation to find the critical points, and then we test values around those critical points to determine the correct interval or intervals. So in this case, I'm going to solve the absolute value equation. The absolute value of x minus 3 is equal to 1. Now that gives rise to two cases. Case 1, x minus 3 is equal to 1. Adding 3 to both sides, we get x is equal to 4. And that's our first critical point, which I've shown on this number line here. For case 2, we have x minus 3 is equal to negative 1. Adding 3 to both sides of this equation, we get x is equal to 2. And that's our second critical point. And I've shown that on the number line as well. The next step is to test the inequality, whether it's true or false, using values around the critical points. And the values that I've chosen are 0, 3, and 5. 0 will be around here, 3 is here between the 2 and the 4, and 5 is up here somewhere. So testing x equals 0 by substituting 0 into the left-hand side of the inequality, we have the absolute value of 0 minus 3. And the absolute value of 0 minus 3 is equal to the absolute value of negative 3. And the absolute value will turn that negative 3 into a positive 3. And 3 is not less than or equal to 1, hence it's false. And I've shown that with a cross on this part of the number line. Testing x equals 3. 3 minus 3 is 0. The absolute value of 0 is 0, and 0 is less than or equal to 1. So it's true, and I've shown that with a tick here. And that's this interval between the two critical points. Finally, testing x equals 5. 5 minus 3 is equal to positive 2. The absolute value of positive 2 is positive 2, and 2 is not less than or equal to 1. Hence it's false. And I've shown that with a cross here. Note though that the critical points are shown with a closed circle because the endpoints are included in the solution because the inequality shows a less than or equal to symbol there. So putting that all together, this is the correct interval. We have x is greater than or equal to 2 and less than or equal to 4. Using a graphical solution to solve the inequality, we graph y equals the absolute value of x minus 3 and y equals 1 on the same set of axes to scale. And note the interval on the graph where the graph of the absolute value of x minus 3 is lower or less than the graph of y equals 1. Now, the graph of y equals the absolute value of x minus 3 is a V-shaped graph with the vertex at x equals positive 3 and a y-intercept of positive 3. And the graph of y equals 1 is a horizontal line with a y-intercept of 1. And noting the interval where the part of the V shape is lower than or at the line y equals 1, we can see these are our 2 points of intersection which occur at x equals 2 and x equals 4. And this part of the V shape is below the line y equals 1. Note that the points of intersection are also included in the solution. Therefore, x is greater than or equal to 2 and less than or equal to 4.